Hi, everyone. Welcome to the first ESA Junior Faculty webinar series. So this webinar is co-organized by Biror Aksoy and Ian Chad and Ted Torosi and myself. So this is ESA sponsored. We took the submissions from the NYU world meeting, ESA world meetings, and put this together. So it will run towards the end of August. The format is 20-minute presentations and 5-minute discussions by the discussants. And then we have a 5-minute Q&A from the floor. And during the presentation, if you have questions, we encourage you to enter them through the Zoom Q&A option. And if it's really urgent, you can raise your hand and we should be able to see that and unmute you. I'm sure we won't be able to get through all the questions during the 5 minutes, so we have an after party. So the Zoom session, webinar ends at 11 o'clock Eastern, but from 11 to 11:30, the authors will still hang out in the Zoom, the same Zoom session. And if you have questions, just feel free to ask them and discuss at that point. So without further ado, I'd like to introduce our first speaker, Kirby, who got her PhD from Ohio State in 2018. And then she did a 2-year postdoc at Stanford. And she will be joining Caltech as an assistant professor this fall. And I encourage everyone to take a look at Kirby's website. It's so very well constructed. So in addition to experimental economics, she also works on decision theory, IO, and microtheory. So I'm going to just unshare and give Kirby the floor. Okay, so take it away to Kirby.
Okay, great. Let's see if I can get this to work. Okay, so thanks everyone for coming. So I'm going to be presenting this paper titled When Choices Are Mistakes. So this is joint work with John Raybeck, who's at Ohio State, and he's here today. So he'll help field some of the questions in the Q&A if you have them. Okay, so the motivation for our paper is actually pretty simple. So decades of empirical evidence has documented violations of canonical choice axioms. So think things like transitivity and the independence axiom. So when we see a violation like this, there's two possible interpretations. So the first is that these are intentional deviations from the axiom. So individuals aren't following the axiom in this instance because they don't want to follow it. So they might be following some weaker version of the axiom, or they might be motivated by some behavioral axiom or something like this. And maybe just implicitly, this is sort of the interpretation that the literature, I think, has focused on. The second interpretation is that these violations of the axiom are something more like a mistake. So individuals might want to follow the axiom, but they might just have a hard time consistently making choices that are in line with what the axiom would prescribe. So in our paper, we're trying to develop a methodology to distinguish between these two interpretations and to see whether we can identify some violations of axioms as a mistake rather than maybe a true preference. And for today's presentation, given the nature of the forum and the short time limit, I'm going to mainly focus on the experimental design because we think this is sort of the important framework for what we're doing and for how we think that we can identify a mistake. Certainly I'll tell you some of the results, but I'm going to have to leave out a lot of details. Okay, so to identify a mistake, we're going to need to do 3 things. So first, we're going to try to directly elicit which axioms, or in the experiment we call them rules, so I'll use those words interchangeably, but which rules people think they should satisfy or that they want their choices to satisfy. Second, we're going to present subjects with questions in which they're going to be likely to violate the axiom. And then we're going to allow them to reconcile these two preferences. So anytime they violate an axiom that they said they wanted to follow, we're going to allow them to reevaluate these choices and to see whether they still think this is an axiom they want to follow, or whether they're going to update using this violation and say, maybe this isn't such a good axiom after all. So, I want to be very upfront about our assumption here. So we're going to be interpreting revised choices as sort of correcting a mistake. So, obviously you can take issue with this, but we think, the revised choices where there's more information and where the full implications of your choices are sort of laid out for you, we think these are less likely to be mistakes than the original choices. And so, we're certainly not the first to think about these ideas, and I'm joined by Dan Benjamin today and Paul Feldman, who both have great work on this paper, and you'll see, both great work on this topic, and you'll see Paul's paper after this. But we think our contribution is to sort of put all three of these pieces together into one framework and to incentivize all these decisions so that we can sort of incentivize the revelation of mistakes. And so we're gonna be looking at the domain of risky choice. And so we chose this domain intentionally, but it's also sort of incidental. So, there's a long history of normative theory, which we think makes this domain particularly interesting to look at this question. But if you're not interested in decision theory at all, I think that's okay. We think that you could use this methodology in many other domains to identify when individuals are making mistakes and to also elicit the decision processes that people want their choices to satisfy. Okay, so I'm going to jump straight into the design. So there's going to be three main parts to the experiment. So in the first part, we're going to directly elicit which of our axioms subjects prefer to follow. So there's going to be, a lot of difficulties when we're trying to do this, as I'm sure you can imagine. So just a few of them. We're going to try to represent the axioms so that they're easy for subjects to understand. We're going to need to incentivize the choice of which axioms individuals want to follow. And we're also going to try to isolate other things that might be going on. So think, there's a lot of things, but think like demand effects and confusion and that sort of thing. So in the second part, we're going to ask lottery choices, which are related to the axioms. So this is, your typical choice experiment. We're going to see whether individuals are consistent with the axiom. And here our goal is just to maximize potential violations because our main interest lies in when choices violate the axiom. And then the last part, we're going to give subjects the opportunity to reconcile these inconsistencies. So our main goals here, again, we want to minimize demand effects. So we don't want subjects to make their choices consistent just because they think the experimenter is pointing out to them that they did something wrong. And we also want to incentivize these reconciled choices without just directly paying for subjects to make their choices consistent. Okay, so I'll go through each of these parts in turn. So the first part is eliciting the axiom. So the question is, how are we going to represent and then incentivize the choice to satisfy a choice axiom? So we're going to incentivize this decision by using the axiom to automatically implement choices on subjects' behalf. So what do I mean by this? So take as an example, independence of irrelevant alternatives, which is one of the axioms that we study in our experiment. So to remind you, independence of irrelevant alternatives says that if you choose a lottery P over lotteries Q and R, then you would also choose lottery P over lottery Q when R is not available in the choice set. So it just says that this unchosen lottery R isn't affecting your choice between P and Q. So to incentivize the decision to say, I think my choices should satisfy IIA, first, we're going to have the subject choose lottery P over lotteries Q and R. And conditional on this choice, then we're going to choose lottery P over lottery Q for you. So you're not going to get the choice between P and Q, but we're going to use your earlier decision to implement this choice on your behalf according to what the axiom prescribes. So this is exactly what subjects see in the experiment, give or take some Z-tree formatting. So as you can see, there's a few details here. So first, we represent lotteries using these colored circles. So I'll tell you exactly what the colored circles represent on the next slide. But you can see here, these black, gray, and white circles represent these lotteries P, Q, and R that I was referring to. So this axiom says, given the choice between these three lotteries, black, gray, and white, you picked this one, let's call it the black lottery. Then in the choice between black versus gray, we would pick the black lottery for you if you decide to use this rule. And so the subject's only choice here is, to decide whether they like this rule or not. So they're selecting, yes, I want to use this rule, or no, I think maybe there are some situations where I would want to choose gray over black, or for whatever reason, I don't want to use this rule, and I'm going to make this choice on my own. Okay, so the circles represent weekly positive money lotteries. So we tell the subjects that the payoffs from these lotteries can be anything from $0 to $30, and the probabilities can be anything from 0 to 100. We also tell the subjects that the colors don't have any inherent meaning. So for example, gray is not in any sense in between black and white or anything like this. These are just three different lotteries. And when subjects are deciding whether they want to follow this axiom or not, they know this domain, but they don't know the specific lotteries corresponding to these circles. So they know that these can be any 3 lotteries with these specific, in this payoff range and in this probability space. And the reason why we do this is because we're really trying to elicit a preference for the axiom itself. We're not trying to elicit a preference for specific instances. So we want to know, for example, do you want all your choices to satisfy IIA, not do you want just specific choices to be consistent with the axiom? Okay, so here's how we would pay you if an axiom were chosen for payment. So again, let's stick with our IIA example. If independence of relevant alternatives were chosen for payment, here's how we would pay the subject. So first we would present the subject with 3 lotteries. The subject would choose their most preferred of these 3. Let's call this the black lottery. So that's this first choice here. If the subject did select this axiom, then we would just pay them a realization of the black lottery as the second row, the choice of black over gray. If the subject didn't select the axiom, they said they wanted to make the choice on their own, then we would present them with this choice here, the black lottery versus the gray lottery, and we would pay them a realization from whichever lottery they select in this second choice. So the difference is whether we make this second choice on the subject's behalf or whether they're faced with this choice themselves. And again, just to reiterate, if IIA were not chosen for payment, the subject would never see these lotteries. So they don't have any information on them aside from knowing about the domain until they make their choice if it's chosen for payment. Okay, so why do we think that this incentivizes subjects to reveal their preferences over axioms? So if you don't think the axiom always should be true, then you shouldn't select it, because the payment lotteries could be any lotteries in this domain. So if there are any instances where it wouldn't be true, then you shouldn't select it. Here we're assuming that there's no cost to making a decision on your own, but barring that, if you do think that it always should be true, then you have at least a weak incentive to select the axiom. Because the rule is going to automatically implement your preferred choice. So you're going to get what you would have chosen anyway, and the axiom will choose it for you. Now, as I mentioned, this is only a weak incentive. Subjects could be indifferent between selecting the axiom and not. So in another treatment, we have a strict cost to make the choice on your own, which makes this strictly incentivized. I won't have time to talk about that today, but the patterns of our results are identical. Okay, so just briefly, I won't really get into the details. We study 6 axioms. So we intentionally just start really simple. We study independence of irrelevant alternatives, transitivity, first order stochastic dominance, the independence axiom of expected utility, branch independence, and what we call consistency. Okay, so there's a lot of other things that could be going on here, as I'm sure you've come up with a lot of other things in your head. So just a few of them, like, what if people just like to follow rules, or they think they should follow rules, or they think it's easier than making choices on their own? So we're also going to present the opposite of each axiom, which we call not axioms. And we use this little symbol here in front of each axiom. And we're going to use this as our benchmark for how often subjects just like to select rules or have other things going on, or might just be confused. We're also going to use this to benchmark the direction of our reconciliation and see, if subjects reconcile their choices, in which direction do they do so. So this is what IIA looks like, and this is what our not IIA looks like. We just change this circle here from choosing black to choosing gray. So this says if you choose black over gray and white, we're actually going to choose gray over black for you. So for each of our axioms, we're also going to present the opposite of the axiom. Okay, so the second part, as I said, this is more in line with your typical choice experiment. So we're going to give lottery questions related to the axioms, although the subjects don't really know how the lotteries relate to the axioms. So we picked, or John at least went back into the literature to just find these papers where we've seen these classic violations of the axioms. And so we just used different lottery choices that were in line with these types of parameters. And again, I want to emphasize, we picked them intentionally to get violations. So in no sense should you think of these as being representative of the axiom as a whole. So I don't have enough time to go into detail today about the specifics, but you can think of things like the decoy effect, certainty effect, this kind of thing. And for each axiom, except for one of them, we have multiple questions with different types of violations. And just to flag, these lotteries are different from the lotteries that would be used if the axiom were chosen for payment. So those black, gray, and white circles in the example before, these lotteries are going to be different from those. Okay. Finally, and perhaps most interestingly, we're going to give subjects the opportunity to reconcile any inconsistencies between their axiom choices and their lottery choices. So how we do that, so here's an example of what the subject screen would look like. So the things that are shaded in this, greenish color are what the subject chose. So here we're saying, in the first part, you selected this axiom here. So you said you wanted your choices to be consistent with IIA. But then when we presented you with these 3 lotteries and you chose this one, but we presented you with the same, black and gray lottery in a different decision, and you actually chose a different one. And so we try, we color code these things corresponding to the colors in the axiom so that subjects have an easier time understanding. We also explain on the bottom, we try to use, as neutral language as possible. So we try to say, the axiom, or this rule would have selected something different for you. We try not to call it like inconsistent in this kind of thing, but we just simply say, the rule would have selected the black lottery here, or the rule would have picked the same thing between these 2 options. And so we don't require subjects to make their choices consistent, but we allow them to revise any of their choices. So for example, a subject could change their choice in the second lottery decision and choose black in both cases, or they could choose gray in both cases. The subject could vacuously satisfy IIA. And also importantly, the subject could look at these lottery choices and say, these are really what I want. And so maybe it turns out that I don't like this axiom after all, and I don't think that it should describe my choices. So we tried to make it so that, if subjects wanted to make their choices consistent, there was no natural, benchmark for which way the reconciliation would go. So if subjects are just trying to make their choices consistent as a form of demand effect, then we hypothesized we would see sort of a 50-50 direction of what they would change. We also allow subjects to reconcile their not axiom violations. So here's a subject who actually was consistent with IIA, but they selected the opposite version of IIA as an axiom. So we let them reconcile this too. And you should think of these reconciled choices as just sort of doing the first part and the second part again. So if the reconciled rule were chosen for payment, we would pay it in the same way as the original rules. So if the subject kept the rule selected, we would use it to make a choice for them. If the subject unselected the rule, then they would make the choice on their own. If a reconciled lottery were chosen for payment, we would just pay them a realization from whichever lottery they ended up choosing in the end. And just to point out, these choices aren't overturning the original choices. These are just in addition to the original choices. Okay, so quickly I'll go through some of the results. So the results I'll show you today, we had 110 subjects. These are pretty standard protocols. We ran this at Ohio State in person. As I mentioned, we have this we have a robustness treatment with 114 additional participants where our results look the same. Okay, so here I'm showing you every subject's choice for the axioms. So these are the axioms on the bottom. You can see there's some heterogeneity, but I'm not really gonna focus on that today. So the darkest portion of the bar is subjects who selected only the axiom and they didn't select the not axiom or the opposite version of the axiom. So you can see that's about between 70 and 80% of subjects. The darker gray part is subjects who selected both the axiom and the opposite version of the axiom. So this is 5 to 10% of subjects. This gray color is people who selected only the opposite version of the axiom. So this is pretty rare. And then we have about 10% of subjects who selected neither. So you can see, first of all, there's a huge separation between the axioms and not axioms, which is good news. So it's not just that subjects have no idea what's going on or they're just selecting these rules for whatever reason. And it seems to be the case that subjects really, they seem to think that their choices should be in line with these traditional axioms. Okay, so then what happens when subjects violate the axiom? So I don't have time to get into all the details, but here I'm showing you conditional on selecting an axiom and then violating it, what do subjects do in the reconciliation? So we have 782 instances of axiom violations. The percentage of subjects who revised their choice is 63% overall. So 63% of violations are reconciled. So subjects change something conditional on violating the axiom. Conditional on reconciling their choice, 80% of subjects change their choices to be consistent with the axiom. So in 80% of these reconciliations, subjects are changing their lottery choices to be consistent with the axiom, rather than inferring from their inconsistent choice that they don't want to follow the axiom. So here I'm just breaking it down by axiom. So you can see, the sample sizes vary widely for different reasons. But overall, subjects are overwhelmingly changing their choice to be consistent with the axiom. So we have 2/3 of inconsistencies reconciled, and they're reconciled in the direction of being consistent with the axiom. Okay, what about our benchmark, these not axioms? So remember, just overall, we had 63% revise and 79% revise to be conditional with the axiom. So for our not axioms, we see the same 2/3 of subjects are reconciling these not axiom violations, but we see the pattern of reconciliation is quite different. So here only 44% of subjects are reconciling their violations to be consistent with the not axiom. And recall that we sort of hypothesized this sort of 50-50 split if subjects were just changing their choices to be consistent as a form of experimental demand effect or something like this. But this is sort of what we want to emphasize. So lottery choices inconsistent with the axioms are significantly more likely to be revised than the lottery choices that are inconsistent with the not axioms. And vice versa, the axioms themselves, the not axioms, are more likely to be abandoned than the axioms. So it seems like, for these, axioms of consideration, subjects really do think that they should follow them. And when they don't, they change their choices to be consistent with the axiom. Okay, so I don't know, my time is basically running out, but so as I said, there's some, nice work in this area. So there's some great old papers that tried to do similar exercises in a much more, kind of unstructured and unincentivized way. But if you're interested in this topic, these are great. And there's also a lot of recent work looking at revised choices. So as I mentioned, I'm joined by Dan and Paul and Zach, who have papers on this topic. And I think Paolo's here too. Yeah, I think this is an interesting area for work these days. So there's countless papers showing violations of these axioms, as we also show. But in addition, we show sort of ex ante, it seems like people want their choices to be consistent with these axioms. And when they're not consistent, people change their minds. Okay, so just to conclude really quick, so our experiment measures direct preferences over fundamental axioms. So we find that individuals agree with these axioms maybe more than we would have thought, given that there's a huge literature showing how often people violate the axioms. It actually turns out that subjects view them very favorably. And then we look to see what happens when the revealed lottery preferences conflict with the revealed axiom preferences. And for our reasonable axioms of interest, people change their choices to be consistent with the axiom. And for our sort of unrealistic axioms, people are more likely to change the rule. Yeah, so certainly this is not the final word on any of this, but we just think this is a first step, or one in a number of first steps, showing that some of these violations may be better thought of as mistakes. And yeah, so that's it.
Great, thanks, Kirby. So we're going to move directly to the discussant. So Dan, you're the discussant, right?
Yes, looks like I can't share my screen until Kirby unshares her screen.
Easy, perfect, thank you.
Okay.
Great. Let's see. No. Okay. Let's do full screen. Can you see, does it look like full screen for my slides?
No.
No, okay. How about now?
Good, yeah.
Great. So it's a real pleasure to discuss Kirby and John's paper. It's a great paper on an important topic. I'm going to focus my brief discussion on placing the paper in the context of the literature, which Kirby had to rush through, and then offer some constructive critical comments. So let's see. Okay, so the idea of this paper is to learn about normative preferences by offering subjects an opportunity to revise choices that they've made that are inconsistent with a normative axiom, and see whether they do or do not revise their choice or abandon the axiom. There's a small literature that builds on the same idea, and one way to categorize the experiments in the literature is into three types. One is to make no reference to axioms and just have subjects make choices, and then when they violate an axiom with some later choice, ask if they want to revise that choice or one of their earlier choices. And I've listed here some papers of that type. Paul Feldman's next paper that he's going to present is in this type of experiment. A second type of experiment is to ask people to make choices under different framings of the same problem according to some axiom. And then if they're inconsistent, ask if they want to revise one or the other of their choices. Or another version of this is to just present two different framings of a problem together to a subject and have them make the choice under both frames together. Again, making no reference to a normative axiom. So my paper with Mark Fontana and Miles Kimball is an example of this type of experiment. And then a third type is to explicitly present subjects with normative axioms, and then in cases where they've violated their axiom with a choice, ask if they want to switch their choice. So the paper that Kirby presented is in this third type of experiment. Now there's a basic trade-off or challenge to this type of experiment, which is in the cases where we see subjects not accepting an axiom, we want to separate the possibility that it's a well-considered rejection of the axiom, they really don't endorse the axiom, from just a failure to understand what the axiom is, or a failure to apply it in practical situations. And so a way to try to get them to understand the axiom is to present the axiom explicitly, what I would call a kind of more heavier-handed type of experiment, like this third type of experiment. But there's a trade-off, which is that the heavier-handed approach helps subjects understand the axiom, but could lead to a stronger demand effect to conform with the axiom. So I think these three types of experiments are complementary with each other, differ in terms of how they make this trade-off. So this particular paper, I think I would highlight three contributions. I think it's a particularly nice design and implementation of the basic idea. The choices are incentivized, which I think people might disagree about how important incentivization per se is, but one of the values of it is that it allows the experiment to measure the willingness to pay to follow an axiom, which I think is quite interesting. So now I want to say something about the demand effect, which is a fundamental challenge for this paper and for the other papers in this literature. And this is the possibility that subjects are pushed toward resolving inconsistencies in favor of the axioms. So to address that potential problem, this paper uses not axioms as benchmarks. So for example, the not transitivity axiom says if A is preferred to B and B is preferred to C, then C is preferred to A. So the opposite of the usual transitivity conclusion. And that gives Kirby and John a benchmark for how often subjects are going to choose a rule over their own choice, when it's just some rule. But I think one might have the concern that these not axioms differ from the axioms, not just in terms of normativity, but in another way, which is that the not axioms are just not very attractive rules to follow. And so they may not provide a very good benchmark for the axiom, since we're not really holding that attractiveness constant. And there's two different ways one could think about to try to put the axioms and the non-axioms on kind of a more level playing field in terms of attractiveness. One would be to try to make the axioms less attractive by, for example, presenting arguments against them, giving reasons to subjects why they might not want to endorse the axiom. And some of the prior work in this literature has done something along those lines, giving arguments for and against axioms. Another approach would be to try to choose the non-axioms in a different way than making them negations of the axioms, but instead choosing rules that, while not normative, are nonetheless attractive to people. So for example, a rule that exhibits a preference for certainty, or a kind of max-min choices in Ellsberg paradox type lotteries, or a rule that's consistent with anticipated regret that we know a lot of people feel. So that could, and potentially serve as a different kind of benchmark. So let me just end again by reiterating, I think this is a really important topic and a great paper, and I hope that future work builds on what Kirby and John have done.
Thanks, Dan. I don't know what I'm supposed to do, if I'm supposed to talk now.
Just go ahead and maybe spend 1 minute to address some of the issues.
Yeah, great. Yeah, so thanks a lot for discussing the literature that I had to skip, and for your comments. Yeah, so I totally agree with sort of this distinction. So we see it sort of as a feature rather than so much of a bug that we kind of directly elicit the axioms, because we think, rather than, we're kind of letting subjects see inconsistencies in their own preferences. So some of the other papers in the literature, sort of would just give subjects the axiom and sort of show them that they chose not in line with this. And so we thought it was really valuable to elicit both of these things from subjects. Yeah, so of course this does make the inconsistency very salient, or very heavy-handed, if we want to call it that. So I totally agree with that. So we tried to use this not axiom benchmark, but I agree with you that obviously the not axioms are much worse rules. So we thought, given the inconsistent choices with the axiom, this is sort of our version of making the axiom less attractive. So we tried to pick sort of these instances where the axiom is least attractive. So for example, like this certainty effect or things like this, these were the questions that we gave in the lotteries. So when we sort of gave subjects this the opportunity to violate the axiom that might be most attractive, to sort of show them, hey, maybe this axiom isn't exactly what you thought it was. And then we still see the revisions in favor of the axiom. So we could have done, sort of weaker versions of these axioms, or something more like a heuristic, which I think is what this last bullet point is talking about. And I think that would be really interesting. We just wanted to start kind of in the simplest way we could, with the simplest benchmark that we could think of, and rather than introducing some more complications and things like this, in making sort of, what do I want to call it, like, axioms with some caveats and stuff like that. But we totally take the point, and we tried to do as much as we could to address the demand effects. But I think our main point is not to look at the levels of these things, but to show that it does seem like there's some difference when subjects are faced with this normative axiom. But thanks a lot for the discussion, and yeah, I really appreciate your points.
Yeah, so there are some questions in the Q&A. I'm going to defer them to the end. So let me just go ahead and let Ted introduce Paul, and we start with the second talk. So Dan, if you unshare your screen. Thank you.
Yeah, so now I can't get back to the main Zoom screen to unshare.
I think at the top, if you bring your mouse to the top, it might hover, and there's a, yeah.
Okay. No,
You've done something.
Thank you. Yeah. Oh, let me, okay. Yeah, I'm not sharing anymore, I think.
Right.
Oh, yes, we're sorted, yes.
Yeah.
Well, right, so I'm very happy to introduce our second speaker today. It was Paul Feldman. Paul got his PhD last year, 2019, from UCSD. He's now in the Department of Environmental Health and Engineering at Johns Hopkins. Paul studies individual choice, especially preferences over risk and time, and is in fact talking about preferences over risk in a paper that's very nicely complementary, I think, to our first paper. So Paul, if you're ready to go ahead and share, the floor is yours.
Okay, can everybody see my screen? Okay, thank you. So the title of our paper is Revealing Risky Mistakes for Revisions, and this is joint work with Zachary Brigg, who is going to be fielding your questions, especially technical questions. So let me briefly tell you what this paper is about. So I hope Kirby has convinced you that when subjects make choices, they sometimes make mistakes. But identifying when these mistakes happen, when we're eliciting preferences or distinguishing from preferences, is tricky. Now, the reason we care about distinguishing mistakes from choices is that we want to use economic models to summarize observed behavior. And in doing so, accounting for mistakes makes our models more robust. Okay? Now, our approach is a dual approach. So basically, the first part of our approach is to allow subjects to revise a subset of their choices. And then our second approach is to use various normative benchmarks to contrast the choices between the original sets of choices and the revised set of choices. This allows us to identify mistakes. And this is a great tool to both reduce and identify mistakes. Okay? So let me start with a brief quote by Nick Mill. If you don't know where you make your mistakes, that's your worst mistake, not knowing where your mistakes are at. And besides this being motivational for a paper, this quote is based on a tweet that has since been deleted by Nick Mill, suggesting that the author himself believes this quote or this tweet to be a mistake. Okay? Now, how are mistakes and choices related? Well, mistakes are a feature of decision making. Often when we make choices, we make mistakes. And researchers often call certain patterns of behavior mistakes. For example, present bias or framing effects. Now, decision makers may not agree with our characterization of what a mistake is. And this leads naturally to a research question. How do we identify mistakes when the preferences are unknown ex ante to the experimenter? Okay, so the way in which we're going to identify mistakes is by using revisions. So as I told you before, this is a dual approach. So first, we're going to allow subjects to modify a subset of their original choices. And then we're going to evaluate the original choice set against the revised choice set using various normative criteria. And the normative criteria that we're going to use are fairly standard in this literature. So the first criteria is dominance. Do people choose dominated alternatives? The second benchmark is rationality. Can we represent the choices that subjects make in this experiment using an increasing revealed preferred transitive and complete relation? And then we're going to extend this idea of revealed preferences to two functional forms. In this case, probability weighting, which nests both prospect theory and rank dependent utility in our context, and also expected utility. And we're going to ask, can probability weighting rationalize the choices that we see subjects make? And can expected utility rationalize the choices that subjects make in our experiment? And finally, we're also going to look at risk aversion and stationarity, where stationarity just means that subjects choose consistently. So this is the consistency axiom in Kirby's paper. Subjects choose the same alternative when faced with the same decision problem. Okay, and the ones that are starred are the ones that I'm going to have time to go over. The rest are going to be in the paper. Okay, and once again, here the tricky part is optimal choices, or what optimal choices would be for the subjects, is unknown to us ex ante as experimenters. And we care about doing this because it allows us it allows us to do more robust inferences on the behaviors we observe. Okay, so the risk task that we're going to employ is taken from a linear budget task from Androni and Harvey in 2009. This is an unpublished working paper where subjects are going to be choosing over binary lotteries or simple binary lotteries. What's a simple binary lottery? Well, a simple binary lottery is a lottery that gives you a p chance of a positive outcome of X dollars and a 1 minus p chance of $0. So here the pertinent trade-off is going to be between the chance of getting this positive outcome P against the size of the price, or X. Okay? And one way to think about this decision task is you could think about a student who's looking hopefully at another smarter student exam. This student is clearly trading off the probability of not getting caught against potentially increasing their grade. Okay, so our experiment had two parts. So for part one, and this part I'm going to call choices throughout the presentation, subjects choose over 25 budgets twice, but in a different order. And then part two, the revisions part, this set of choices I'm going to call revisions. And this is going to be formed by 14 of their original choices and 36 revised choices. So we're going to give subjects a chance to revise 36 of their original decisions. And we're going to vary the types of revisions that subjects can make. So for half of their revisions, subjects are going to be reminded about what they chose before. And for the other half, they're not going to be reminded about what they chose before. And we're also going to have them either revise a single decision, or we're going to have them do a dual choice. When they do a dual choice, they're picking always over the same budget. So they're facing the exact same decision task. So they're overriding both of their previous choices from the choice part. Okay, now what do we find? We find that mistakes reduce our ability to explain behavior. Mistakes are common. Over 75% of choices are revised when subjects are given an opportunity to do so. And 50% of these revisions are substantial. So what are our main results? We find that revision types, in this case, having them revise 2 decisions at once and giving them reminders actually affects revision behavior. We also find, and you could call this a continuous version of the certainty effect that Dan and Kirby both talked about, where the more unlikely the binary lotteries are, the more likely this decision is going to get revised, and the magnitude of the revision is going to be larger. And finally, we find that revisions improve all of our normative benchmarks, justifying the characterization of mistakes that Kirby just gave you, that original choices that are revised or changed are actually mistakes. And yeah, okay. Now, I'm not going to have time to go over the related literature, so let me skip over this slide. And let me go straight to the design. So this is a sample task from our experiment. As you can see, when they began the task, the only information that was displayed to subjects was the maximum outcome that they could achieve and the maximum probability they could select. Once they interacted with the slider, they could use the slider to trade off the chance of that positive outcome against the size of that positive outcome. And if they chose a corner, they assured themselves a certain outcome of $0. And before proceeding to the next task, they always had to first interact with the slider and then verify their choice below. Okay, one way to think about these decisions is using the standards 2 goods diagram. So you could think of the X good as money, and you could think of the Y good as the probability of getting set price. Okay, and here budgets are going to be, linear budgets are going to be uniquely determined by the maximum outcome and the maximum probability. So in this instance, where the maximum outcome was $50 and the maximum probability was 50%, subjects could potentially choose a 25% chance of $25. Okay, so how did we do this? 181 University of Queensland undergraduate students participated in our study. It took them about 30 minutes to complete the study. We pre-registered our design in the AR RCT registry. Each subject made 50 choices and revised 36 of those choices. So when I talk about the 50 original choices, I'm referring to these original choices. And when I'm talking about the revisions, I'm referring to the set formed by 14 of the original choices and the 36 revised choices. Okay, and in terms of payoffs, subjects got a $10 show-up fee. The average payment was $9.50. And we used an incentive compatible pay one round at random. And here, let me just emphasize, the round that we paid was over the revisions. So because they didn't know which choices would get revised, this is incentive compatible. Okay, now before I show you our main results, let me just remind you what a violation of rationality looks like. So here we have that L2 was chosen on the $100 budget line, and L1 lies strictly below L2. So this means that L2 is being strictly revealed preferred to L1. And you could use the exact same argument to show that L1 is being strictly revealed preferred to L2. So this is a violation of rationality because we can't have L2 being strictly revealed preferred to L1 and L1 being strictly revealed preferred to L2. Okay, now this is a binary test. You either are consistent with rationality or you're not, and this is a well-known problem in the revealed preference literature. So people have devised other measures of rationality that are more continuous. So one way in which we could quantify the magnitude of the violations is by asking by how much we would have to scale down the budget in order to get rid of this violation. So in this case, we're scaling down the $100 budget to $75. And this would mean that L2 is no longer strictly revealed preferred to L1, but only weakly revealed preferred to L1. So in this case, the rationality index would be 0.75. If the rationality index would be 1, that means we didn't need to scale back the budgets. And if the rationality index were 0, that would mean that we would need to get rid of the budget altogether in order to rationalize behavior. Now, we could do the same exercise with the other budget. And in this case, we would only need to scale it down to 0.8. So the AFRIAD index is the minimum scaling down that we can use in order to get rid of all violations of rationality. So once again, higher AFRIAD indexes mean higher consistency with rationality. Okay, so this is our main result. So on the y-axis, I have the fraction of subjects that are greater than a specific number for the AFRIAD index. And on the x-axis, I plotted the different AFRIAD indexes. So as you can see, the red curve, which corresponds to the revisions, lies strictly above the purple curve, which corresponds to the original choices. So this is showing you that the fraction of subjects that clear a specific AFRIAD index is always higher for the revisions than it is for the choices. Furthermore, I've also added a yellow curve, which corresponds to random choice. And this is basically to give you a sense of the power of the test, where the null hypothesis here is that subjects are choosing randomly. So at least we can reject for both their choices and their revisions that subjects are completely choosing randomly. Okay. And now in terms of some summary statistics, the median AFRIAD index for the red line is going to be 96%. Clearing the variant 95% suggested benchmark. And for the choices, this median statistic is going to be 93%. Okay. Now, we also redo these revealed preference tests for specific functional forms. So the specific functional forms we consider are probability weighting, which again nests prospect theory and rank dependent utility in this context, and for expected utility. And as you can see, our results don't change if we apply these stricter normative benchmarks. So here we're asking the question, could a probability weighting function rationalize the choices that we observe? And again, we find that revisions outperform the original choices across both of these specifications. And just to give you a sense of the magnitudes, the median AFRIAD index for the revisions for probability weighting is 95%. And for the choices, it's going to be 93% AFRIAD index for probability weighting. And you can contrast this with expected utility, which are much lower. We have a median AFRIAD index of 87% for expected utility for the revisions, and 81% for choices for expected utility. Okay. Now, here the punchline is across all of our normative benchmarks, we find a significant improvement from the revisions to the original set of choices. And before I show you some of the determinants of mistakes, let me just briefly walk you how we standardize the magnitude of changes. So the way in which we will do this is simply by framing everything in terms of budget shares. This allows us to keep the magnitude of changes across budgets standardized. Okay, so in this instance, the budget share difference was 25%. Okay, so 25% more of the budget was allocated to probabilities than to outcomes. Okay, and just to briefly remind you, there were 4 treatments, or there were 4 types of revisions. So here is a sample where we're doing a dual revision with reminders. As you can see at the top, the maximum gain and the maximum chance are fixed. So this is, the budget is fixed. And we've given the subjects reminder as to what they chose before. Okay. Now, what is the effect of these different types of revisions on the magnitude of the revision? Well, we find that reminding subjects about what they chose before actually lowers the magnitude of the revision size. Furthermore, double choosing twice tends to decrease the magnitude of revisions. Now, this slide, and this is my final slide, it summarizes 2 findings. So the first finding is that experience reduces both the chance that subjects will make a revision and the magnitude of that revision. And it also tells us, or it also characterizes what I've been calling the continuous version of the certainty effect. So as you can see here, the maximum probability for a task, this is the maximum chance that subjects can allocate in a task. Actually, the lower the maximum probability, the more likely that a decision is going to get revised, and the magnitude of the revision is going to be higher. Now, let me just finalize with some final remark, because I'm not going to have time to talk about decision times, but decision times are in the paper. So one thing that we do find is that decision time is positively correlated with revision size after controlling for some factors, suggesting that the longer a subject spends on a choice, the more likely that it's going to be revised and the higher the size of that revision. Well, thank you very much, and I look forward to your question and discussion.
All right. Over to you then, PJ, for discussing.
Yep. Thank you very much. Thank you for inviting me to discuss this. I'm not nearly as prepared as Dan was with slides, so I'll just talk for a minute or two, and we can have Q&A and chat afterwards. Yeah, so this is an interesting paper. It's a nice paper. I don't have any work in this literature, so I'm much less informed, so I'm more of an outside observer to this. You know, I think you define, when people change their choices, you define it as a mistake. And I guess the question is, you know, are we sure it's a mistake? Are there other models that could explain this kind of behavior? And I think your results are really interesting because, you know, you might think that it's just randomness. There's like some randomness in people's choices, like a stochastic choice kind of thing. And that might explain why people change their choices. But you do find that consistency improves on the revised choices. So I think that's the interesting thing for me, is that it's not just that people change what they do, it's that they somehow get better and, you know, conform more to like the existence of a utility function. You know, that does raise some questions like Dan had about demand effects and whether, you know, whether showing them, you know, we're giving this opportunity to revise somehow makes them more thoughtful about that sort of thing, especially the cases where you could do a double revision, where you could revise the same choice twice. So actually that raised an interesting question for me, which is in those cases where people do a double revision, I wonder if those cases give you more of a shift towards consistency than like the single revision. So for example, if I just look at the subset of double revision choices, would the AFRIA index get even higher on that subset if you could somehow adjust for, you know, the size of the set that you're looking at? you also have this result that when you show people their past choices, they tend to revise less often. So this reveals kind of this preference for consistency, which is interesting because that tends to override whatever's causing them to shift their choices from one to the next. Another thought I had is that you have these, the shapes of the budget sets matter for how frequently people revise or make mistakes. I thought that was interesting, and I was wondering if perhaps the shape of the utility function could predict that, whether a more concave utility function or a more flat utility function would somehow be like closer to indifference along certain budget sets and farther from indifference, you know, have like a more unique maximizer in other budget sets. You know, I don't know if you want to do a whole MLE exercise, but you could try to do something. You have enough data, or you could try to do something where you sort of estimate the shapes of the indifference curves and see how close the indifference curves are to the budget lines, or how much utility loss there would be from deviating from the maximum according to that utility function. One literature comment I have, which nobody has mentioned today, there's a paper Colin Kammerer wrote in 1989 that was in the Journal of Risk and Uncertainty, JRU. It was testing these non-expected utility theories, but at the end, so he chose one lottery randomly for payment, and at the end he said to 80 people, he said, here's the lottery that we've randomly chosen for payment, here's the choice you made. Do you want to change your choice now that you know that this one's actually being chosen for payment? Only 2 out of 80 people revised in that case. So like in your paper, you're seeing a lot of revisions, like 3/4 of things are revised. Kammerer's paper was really similar, and he only got less than 3% of people revising. So it'd be interesting to explore, you know, what the heck's the difference between what he was doing and what you're doing, and see if you can uncover some reason why he didn't get revisions and you did, and what might be driving that. It also kind of then reminds me of this literature on dynamic inconsistency, because one difference between what you do and what Kammerer does is that in his, uncertainty about what's getting paid gets resolved before you get your opportunity to revise, and in yours there's no uncertainty resolved before people revise, and so that might link to the dynamic consistency literature. Yeah, and the only other thing I'll just say sort of in general, this isn't about your paper, but just sort of my rant in general, is I do worry about us as experimenters using surprises too much in the laboratory. So we have subjects that make all these decisions, then we say, surprise, these 36 decisions don't count. You need to now, or I guess you can keep the same thing, but you now have the opportunity to change it. I do worry about subjects not believing our protocols and our instructions if we do surprises too often in the lab. And I'm guilty of this too. I've run experiments with surprises as well, but I think that's something that should be part of the conversation when we do designs like this. Okay, that's really all I have to say. It's a nice paper. Thank you for having me discuss it.
I guess Ted is Ted still here?
I'm still here.
Oh, okay, good.
Yeah, I just have my video off too.
We also have a raised hand.
Okay.
So do we have any? Yeah, I'm not seeing where there are raised hands. So
I don't see the raised hand either. That's
it's in the participant list.
oh, there we go.
Click.
Yes. Now who is it?
Yoram Halevi.
Yoram, yes.
Hi. Can you hear me?
yeah.
Yes.
Hi. I have a question to Kirby. So it was very fast. I couldn't follow exactly the results, but I saw there is quite a lot of heterogeneity across the axioms that you discuss.
Yes.
And so the literature, let's say, focuses on independence. And as far as I saw, it was very fast. So I think I saw something like 50% only, while in other axioms, it was like 80% of revision.
Of the percentage of subjects who revised their choice?
Yeah, so maybe you can talk a bit about, not all axioms are made equal, and the literature has explicitly spent quite a lot more time on independence than on other axioms. So maybe you
Yes.
can elaborate on that.
Yeah, so I just want to caveat before I speculate that we didn't really design the paper to make explicit comparisons across axioms because we couldn't really put them all on equal footing in all senses. And so we have, different types of questions for the different violations. Obviously, we tried to calibrate the expected payments of the lotteries and that sort of thing, but the axioms just look different and the questions are different. So we didn't design we didn't necessarily go in wanting to make these comparisons across the axioms, but yes, you remembered correctly. So independence, from looking at the results, 50% of subjects revise their choices, and 80% of them, or 78, are revised to be consistent with the axiom. So I think it's actually our certainty effect question that's revised the most. I think if we wanted to make a statement about independence itself, then we would probably have to just do one paper designed only to look at independence, to look at all these different types of violations and potentially weaker versions of the axioms. And I think there's actually some people who are looking into that. But yeah, it's actually, we can't really say for sure why independence is reconciled 50% of the time. I don't know if John has any other thoughts, but I think the main point is we didn't really want to, pit axioms against each other. Independence is also, I think, one of the more difficult ones for subjects to understand why their choices are violating independence due to the mixing and that sort of thing. So I think if, we would want to look at a bunch of different ways to elicit the independence as a rule, and also a bunch of different ways to present the reconciliation opportunity if we wanted to kind of make a final statement on independence. So that's my thoughts.
Yeah, so Miles Kimball.
Yeah.
Oh, okay, can you hear me?
Yes.
Okay, so I've started to write some of this in the chat box, but I kind of three overall thoughts about this literature, which, by the way, I think is a very important literature. Partly, I'm voting with my feet, so that shouldn't be surprising. First of all, I think this literature is very important for welfare analysis, and welfare analysis is in turn important whenever people can't make a choice for themselves, like public goods choices, or when it's very difficult or costly to make a good decision for themselves. So mistakes matter both because they mean there are more situations like that. If mistakes are common, there are a lot more situations when it's costly or difficult to make a good decision for yourself. But the mistakes also matter in trying to identify what your welfare criterion. So I think that's really crucial. One of the things to point out about that is I think it's pretty important not to make, I think it's desirable if you can do it to do incentivize, but I think it's important not to make a fetish of that, because I think this is so important in many real world situations, and there are many real world decisions where it's just not practical to incentivize things. So I think it would be a big mistake if we said, oh, we're only interested in this if it's incentivized. That's a plus if it's possible. But there are a lot of big decisions where you're going to have to go hypothetical. Totally separate comment. One thing that I only realized from this discussion today is there's really two very different kinds of axioms. One, unconditional axioms and conditional ones. So unconditional axioms are like, first order stochastic dominance. Everybody should like this kind of thing. Conditional axioms are, if you choose this, then you should also want to choose that. And I think that's really crucial because, like in the paper that Kirby presented, some of the axioms are unconditional, and the way the paper is totally appropriate for those. Others of the axioms are conditional, and then there's a hidden taking, if you make this choice, then you should want to make this choice. And then it's not questioning one of the choices. So take the IIA example. If you could question the choice they made among the three things, right? So if you make this choice among the black, gray, and white, then it implies this choice among just the black and the gray. And so, but there are several things to question. One is maybe I don't like the axiom, which is where the paper Kirby presented goes. But you could also question the choice they made among the three things. So that IIA is a conditional. This may not be the right terminology, but it's a conditional axiom. It's a relationship between two different decisions, saying if you make this decision this way, you should make this decision this way. But instead of questioning the axiom, you could have questioned the original decision. And
this is what we allow them to do when we allow them to reconcile their choices, is we allow them to question either of their decisions or the axiom. So it's true that
you let them question either of their decisions?
Yes. Yeah, they could choose
okay.
either the one with the 3 or the one with the 2 or the axiom or nothing.
Okay, cool. Okay. That's actually very important. I think I would emphasize that more. I think that's, I mean, maybe I just briefly fell asleep while you were doing that or something, but to me, that's really crucial. This kind of, I think it should be clarified. There are conditional axioms, unconditional axioms. With the conditional axioms, then you got to allow people to question either of the choices or the axioms. And I think that now that, okay, that's a strength of your paper that you can highlight more. Okay, last comment, again, somewhat different, is it's interesting, the second paper where you're just letting people change their choices. It's interesting because you could view that as simply letting people make higher quality choices. So I think one way, you know, a broad category of ways of trying to identify what's normative or what, you know, what people's true preferences are as opposed to mistakes is to try to get people to make high quality choices. So, so they're kind of a bunch of different ways, but two to mention are, one is you just give them longer to choose, and letting them modify their choices later is kind of a version of not only giving them longer, but maybe they get a different perspective. But there are other ways to get people to do high quality decision making. I'm thinking of Dan's paper where he's looking at people with higher IQ and the decisions they make as compared to people with lower IQ. So I think it's nice to think of it in terms of a menu of different ways of trying to get people to make higher quality decisions, because looking at the decisions people are making in more nearly ideal circumstances is a crucial strategy for trying to identify mistakes. And, you know, just letting people, you know, the third or fourth version of your decision is arguably a higher quality decision. All right, that's it.
Good. Well, we're a bit after the top of the hour already, and so we promised that I think we're fully into after party time. So again, we'll continue to keep this open and encourage those of you who can and would like to stay around and talk a bit more to do so. But on behalf of the organizers, I would like to thank Kirby and Paul for their talks. I'd like to thank PJ and Daniel for their discussant. I'd like to thank you all for attending, and we'll see you same time, same place next week.
Thanks.
Thanks to the organizers.
Thanks to the organizers too. Thanks for setting this up.
3.
So we are in the after party time. And so at this point, whoever would like to ask questions, if your questions are not answered in Q&A, feel free to raise your hand. I think there's no raised hand at this point.
So, well, Paul, I'll bring up a topic that came up a couple times in the Q&A during your talks, which nobody really addressed, which is decision time, or, you know,
Yeah.
I know, Paul, in your paper, you analyzed decision time explicitly. It didn't make it into the presentation because of time. I don't know if Kirby and John, if you have any data on decision time, but maybe if you guys could talk just for a minute about decision time and what you got there.
So we don't have, so we do have the data, and I don't know all the answers. The one thing that I do know is that subjects who leave their choices inconsistent in the reconciliation stage, they do so very quickly. So I can't say this for sure, but it seems like those subjects just sort of didn't really want to think about it again. So we don't know. This could be because they were like very, very sure that they made the right choice in the first stages. And so they know that they didn't make a mistake and they don't want to change anything. But I think, more realistically, I think it's just, either stubbornness or just, they already made these choices. How bad could they be? They don't want to think about it again. So they just breezed through the reconciliation. So that's the one thing I know about decision times, but we do have decision times from the first stages. So it's an interesting question that we're going to look at of, whether people who make their decisions more slowly in the first place, whether they're more or fewer mistakes and whether they're more or less likely to reconcile their choices. So I'll get back to you on that.
Yeah. So in terms of decision times, as I mentioned during the presentation, we find that decision times are correlated with likelihood of revision and magnitude of revision. And going back to, I think Ian Kravich posted a comment about reminders. We actually find that reminders increase the time of contemplation. So when we give people reminders, they actually spend a longer time thinking about their decisions, or hopefully thinking about their decisions. I don't know what they're doing at that time.
Was it the case that in those they're less likely to change?
Yes.
Oh, okay, so they think about it a lot and they don't change.
Yeah.
That's interesting.
Yeah. So I have a question, more of a broader question about this stream of research. I mean, axioms are supposed to be self-evident truths. And so the question is, one of you mentioned reasonable axiom versus unreasonable axioms. And so are we going to, in the end, have an empirical evaluation, across these different axioms? What are reasonable? What are unreasonable? Or is it purely normative versus positive?
Yeah, it's an interesting question. So there's a part of our paper that I didn't get to present where we asked subjects to rank the axioms. So we were kind of trying to look at this. So rather than just kind of thumbs up, thumbs down each one, sort of which ones do you like the most? We really didn't see any differences. So, it could be because of our procedures, it could be because of a number of things, but it really seemed like individuals just either liked an axiom or not, but they didn't have clear preferences within the set of the things that they wanted to follow. So again, I don't think that's the final word, but I think, yeah, it would be really interesting to kind of create this ranking, and even, so we can survey some economists to see which ones they think are the most normative and see if the pattern is similar. But so we looked a little bit at that and we didn't really find much, but.
One interesting thing I'll mention in the work that Miles and Mark Fontana and I have done is with respect to the reduction of compound lotteries axiom, which is initially one of the axioms with the highest amount of violation. And there's been a lot of research, in decision theory, thinking about, kind of trying to model violations of reduction of compound lotteries. But, we find that after people have a chance to reconsider their choices, then it has one of the lowest rates of violation. So I think that gives an interesting, that's I think suggests that it's mostly a math mistake, and we should not, we should think of it as having a lot of normative force.
Can I ask this is Yoram. Can I ask another question to Kirby? So I'm not sure whether you did it. So basically you pointed out where there was a conflict in the third part, right? In the third part, there was, if there was a conflict, you pointed it out to the subject.
Right,
and
so anytime a subject selected an axiom, either an axiom or one of our opposite axioms, and then made choices that were not what that axiom would have chosen, we showed them the axiom and all the choices and showed them why the axiom would have selected something different.
But you didn't do the opposite, right? We
didn't have reconciliations when they chose consistently with the axiom. Is that what you mean?
Yeah, kind of. Right.
Yeah.
Yeah.
Yeah, or when they made choices that were consistent with an axiom that they didn't select. Yeah. So this was mostly just because of time constraints and cognitive cost constraints. So we had to limit the number of revisions at some level. So I think the number of revisions range from like 0 to 28 or something like this. So, just adding more of these kind of placebo revisions, we just didn't have time. So that's kind of why we use the not axioms a little bit to get at that. But I think it would be interesting to say, you actually follow this axiom all the time, but you didn't select it. And do you want to?
Right. So what I thought is basically the second stage was the lottery, right?
Yes.
Right. So if you would just give the second stage, and then like in the third stage, you would give the same lotteries in the second stage, and then say, hey, there was, check or not check. Do you want to change anything? So would it be much longer? Programming it would be much easier. So because then you don't need to check all the cases where there's right. You don't need to present all, but you just go one by one and just show whether they're.
So do you mean not elicit the axioms in the first stage and just
No,
make?
you can elicit the axioms, but then go over all the questions. So I think it's easy to create a symmetry between revising and not revising if you just do the second stage. And again, with the insight from the first stage.
I'm not exactly sure I know what you mean. John, do you know? So I think
I can't follow.
What?
Yeah, can you try explaining again? Or
so one thing that we have done is just do the first stage and the second stage as we did, but then every single pairing between the axiom and the lottery that could have happened, we could show them that again. I don't know if that's what you mean.
Yes,
so
exactly.
Yeah, so that's where, so I don't know exactly how much longer that would have been. That's interesting. So so I don't know that the programming would have been easier. It was already really hard. So now I understand what you're saying. So we considered these kind of revisions where there wasn't an inconsistency, and we forewent them due to length of the experiment. But I think it would be really interesting to see. So that's a good point. Because we also we had subjects reconcile each violation separately. So if they saw 4 IIA questions and they violated IIA all 4 times, we didn't have them reconcile this all at once, which is maybe part of what you were envisioning. So we had them reconcile each one independently. So it actually is like a lot of revision opportunities. But that's another question that we could have done is kind of look at all the instances of a particular axiom altogether and see sort of, overall, do you want to satisfy this axiom?
Yes, I didn't think about that, but that's a good idea.
Yeah, exactly. And this is why we can't compare across axioms within our study, because the questions are just so different and we have different numbers of each. So
I see. Thanks.
So I don't see any raised hands from the audience at this point, and I think we addressed all the questions.
There's this one, system 2 question.
Right, so I was looking at the person is co-monotonicity raised this.
Yes, they are. Okay, let me read it.
Yeah, we should read that loud because I don't think the rest of the participants can see it. So the question says, if we believe that the modeling device that Kahneman calls system 1 and system 2, then it might be that when making actual choices, they make a choice consistent with system 1. When you confront them then with their choices or axioms and give them some time, then system 2 kicks in and sometimes overrules system 1. So I guess like system 1 is your actual choice making, but then choosing over axioms or revising a choice is more like system 2. But then the complaint is that in the wild, when people get to do a choice again, wouldn't it just be system 1 again? So what do we really expect system 2 to ever kick in the wild, and maybe it's kicking in your experiment? I don't know if you, I mean, I don't know if you have any data.
No, I mean,
I don't know if you can speak to that at all, but yeah.
It's an interesting question. I don't know. I mean, I think it depends on what the wild is and how we design the environment. You know, if you're making choices alongside some principle in the wild, then, you know, like if we're making choices on Amazon and I apply a filter because I know that I don't want, you know, some sort of like procedure that I want to follow, then these are now my choices in the wild. But, you know, I take the point that if we're just trying, you know, if we're trying to describe choices, then this isn't maybe, you know, so basically, you know, we're trying to make the distinction between, you know, normative theory and descriptive theory. So, you know, we're not saying that now our descriptive models are of how you choose are going to change. And maybe this is what we would think of as our system one models, unless we kind of change the choice environment. So I don't know. I think there's a few things going on. I don't know if Paul has any different thoughts.
Yeah, so I don't think we have a clear way of distinguishing between system one and system two, maybe contemplation times, but even there, I would say the evidence is kind of mixed. We don't exactly know which triggers which system. In our experiment, you would think that giving reminders would actually make it quicker for subjects to make a decision. It actually makes it longer. So I don't have a good sense as how one would even go about distinguishing whether system one or system two is the one that's making the choices, or whether which would be the normative criteria that we should use to evaluate different types of decision making.
In the market design domain, sometimes in several scenarios, you know, dominant strategies are recommended. Right? So if you go to the Boston Public Schools webpage, they'll say that there is no point in gaming the system. You should rank the schools truthfully. And the same is true for the National Residence Matching Program. So in lots of cases, there will be recommendations which are consistent with, you know, let's say the dominance axiom, the dominant strategy axiom, what Ted Groves called the dominant strategy axiom, which says that if someone has a dominant strategy, they should use it. And so I suppose these type of policy recommendations can be made in other settings as well. So these are in the wild, but the stakes are really high. So parents would go talk to other parents and think through, you know, whether the recommendation makes sense or not. All right, so if there are no more questions, so let's thank our presenters and discussants. Thanks, Kirby and Paul and Dan and PJ. So we'll see everyone next week. So we had 150 participants today. So very nice. Thank you. Thanks everyone for participating as well.
Thank you.
Thank you.
Thank you.
Thank you.